more than almost ever before, you've got to write these things down, because what I'm showing you is not something that's just going to be like natural. You'll have to go back to these notes to go, which way should I move the function now? All right, so everybody please start with just making an XY chart. That's the number one skill for this next test. Because if I say to graph this, I don't trust that you have memorized what the absolute value looks like. If you have, and you already know, boom, I know what that looks like, I know the graph of that, then you're way ahead, and that's awesome. But most kids aren't going to have this memorized. They're going to have to make a chart, and then make a bunch of points, and then graph those points. So I'll do this one with you. I'll stick you in any point I want, and I like choosing 0 because it makes things 0 a lot of times. So if I put the 0 right here, do you get the absolute value of 0? Means the bars, they just make whatever you put in there positive. They don't make it the opposite, they make it positive. So it's positive 0. So y equals 0, 0, 0. Make a chart with me. Just copy this down. Next, Mr. Neverman, put in a number. 4. Okay, we're going to put in 4. So then, what is the absolute value of 4? Neverman?
4.
Yeah. Y equals, absolute value of that is still 4. 4, 4 is on the graph. Have you got these 2 points written down? Then put in a -1. Everybody remember when I said about this, you always have to put in a negative? One of the kids last hour reminded me that I said that, and it's true. So let's put in a negative. -1 right there. This is the first one where it actually matters that you absolute value it. Damien, what is the absolute value of -1? 1. Now let's graph these points. 0, 0. Ooh, that's a hard one. It's right at the middle. It's where you start. 0, 0. Boom. I got a dot. Now 4, 4. I go over 4 and up 4, put a dot. -1, 1. -1, 1 is like that. Now, this, if I connect the dots, makes a V shape. And did you remember that the absolute value is a V shape? Some of you would have known this, and your life would have been easier because you already knew where the graph goes. Awesome. If you're good at memorizing, this next unit's going to really be nice to you if you're good at memorizing. If you're good at taking notes, this unit will be nice to you because you can look back at your notes and go, oh yeah, the V shape, that's what the absolute value is. All right. The other thing that I'm supposed to remind you today, because I taught it to you and then you had a 3-day weekend to forget it, was domain and range. Underneath this, put D and R. And some of you are going to remember this, and some of you aren't. Asen, do you remember what domain means about like what direction we're going and stuff? It is like left to right. You are correct. So, how far does this function go to the left? See that arrow? It's going to the left forever. What lives way over, way to the left? Negative infinity. What lives way to the right? Infinity. Good. Okay. So this function, if you let it ride, you let it just keep going, do you agree it is going to go forever to the left and it'll go forever to the right? So your domain is forever to the left, which is negative infinity, to forever to the right, which you can use this sideways 8, or if you really like, you can write INF for infinity. Domain is left and right. Do you get that this function goes forever to the left? Because it's got an arrow on it. It says that it's going to the left. It's going up and left, both. And this arrow on the right side is saying it's going to the right forever and up forever. Okay. So now, my range. How low does it go to how high? Don't say it, write it. Put it right there. And remember that if it touches something, it's a bracket. And you'll never touch infinity. This is one of these tests coming on Wednesday of next week where you are going to be asked to remember a bajillion things, like what does range mean? And if you've written it down a few times, it increases the chances you'll remember it. So how low does this one go? Well, low is like the lowest it goes is right there. That's the lowest it goes. And then how low is that? 0. And what's the highest that this thing goes? They're arrows. That tells me they keep going up. Up, 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 up. What's the highest? What's way up there? Infinity. I'm going to write INF just to show you you can. You don't have to use the sideways 8. Yes?
Does it touch on the bottom one?
Yes, very good. I was going to go back to that and say now, is there any place where we need a bracket because it touched? It touched at 0. Bracket. Math rewards careful people. And it also does the opposite. If you're not careful, you can lose so many points on this next test. Oh, I just forgot the bracket. Well, that's a big deal. Okay, I'm going to give you another one. And I want you to tell me its domain and range. Let's imagine for a second that you knew that x squared was a graph that was like a U shape. And then today you're going to learn that -3 means the whole thing moves down 3. And then here's the graph, and it kind of looks like that. So this spot way down here, the lowest it goes, is at 0, -3. Okay. So, what's its domain and range? Write down left, comma, right. L, comma, R at least. That's the domain, is left to right. How far to the left does this thing go? The domain is left to right. All right, write down your answer for the domain. Just the domain, please. And please talk to the kid next to you about what you think the domain of this function is. YouTubers or Parkers? It's YouTube. Back here, it's going to be 3. 2. And then straight across, straight across, straight across. You'll be able to set the 2. Never mind, you're going to go that way. You 2 are going to be there. Moving for the person behind you. I was going to say that. That's the domain of that function. Talk to him. Negative infinity to infinity. Raise your hand if you had that one right. Okay. That just means it goes forever to the left. Infinity means like forever. And forever to the right. How about the range? The range means how low to how high. And normally they stop at 0, but this one went lower than normal. Did you say 0 to infinity, but it touches 0? Oh, I was really close. But no, it moved down 3. So, Remington, what do you say? -3 infinity is correct, as long as your -3 is in a bracket. All right. Maggie, what's your question? If there's an arrow, then usually there's an infinity involved, yes. Yep. But see, there's no arrow down here, so there was no infinity down there. This has an arrow, and that's not only going up, it's also going to the left forever. And so that one is kind of like two infinities. It's up forever and left forever. All right, next thing I want you to write down is a little chart that tells you where the different infinities live. That's positive infinity, because way to the right, that's positive infinity. Way up, positive infinity. Take a wild guess what the other two are. Negative infinity and negative infinity. You can always use I on F or the sideways 8. But down forever means negative infinity. Left forever means negative infinity. Write this down so that someday you can condense it all down into one little like sheet that's got all your notes on it. And no, unless you have a special deal, you can't use a note sheet on the test. But this would have been one test where, this coming test, where the notes would be really handy. All right, so I'll just leave these up here. What if I flip the U shape upside down? Will that change things? It'll change some things, but not other things. If you don't even know what domain means, you're toast. Domain means left to right. Think to yourself, how far left does this function go? How far right does this function go? How low does this function go? How high does this function go? That's your domain and your range. Okay. Have you got this copied down yet? Okay. You need to borrow on an iPad. But okay. You should have said that from left to right, this goes forever to the left and forever to the right. So that's negative infinity to infinity. And the range is how low. I like using low to high because it starts with an L. Just like this starts left to right. This is low to high. And how low does it go? Negative infinity. How high does it go? Doesn't go up forever. Stops right there. How high is that? 0. But it touches there. Who remembered the bracket on the 0? Okay, good. Okay. This is definitely one of those times where the kids that can be really careful on stuff, like don't forget things like that bracket, are going to do well. Okay, so if I gave you a function like y equals x minus 5 squared, there's two things you have to be able to do today. One is to be able to just look at it and go, I know what that looks like, and I know which way you moved it. And the other thing you have to be able to do is make an XY chart to know where the points are. So it's kind of a big day. All right, to start with, let's do the XY chart. You can put in any numbers you want, but as soon as you put in 0, I hope you would realize that the answer gets super big. What is 0 minus 5? Negative 5. What is negative 5 squared? 25. If I put in 0, I get 25, and the problem with that is there's never any graph paper that's big enough to graph that. So your numbers are so big you won't be able to graph them. So on the test, you want small answers that you can graph. So that would have been off the graph. It's not wrong. 0 does give you 25. But always look to try to make the inside part be 0. So what's a smarter number to put in than 0? 5, exactly. So everybody make this XY chart. Start with 5. Put in 5. And when x is 5, it says right here, y equals, and that's what we want to find, is what is y equal to? Y equals what? Well, put in the 5 for x. What's the answer? 5 minus 5 is 0. 0 squared is... Oh, yeah. I'll have to call on individuals because you guys don't want to offer. Now, there's upside to people that are willing to offer answers, because Then I don't have to call on people. But now, if you guys are going to be silent, I'll be just calling on people for the rest of the hour. So, Ruby, give me another number besides 5 that would be a good choice.
6.
Sure. Anything near 5, like 6. Abby Music, tell me how to put 6 in.
Here you put 6 for x.
Yep.
Here's 6 minus 5.
What is 6 minus 5? And then you square it. 1 squared? 1. There you go, 6 comma 1. And if you're like, I don't know how to do this squared thing, well, you'd take your calculator, and that means times by itself. And it was 1 squared, which means 1 times 1. And there's a squared button on a lot of calculators if you want. All right, we suck in 5 and 6 and maybe 7 then. You know, just keep numbers that are close to each other. Pierce, if I stick in 7. 7 minus 5? 2 squared. 4, yep. 7 comma 4. We just put in 5, 6, and 7. Maybe we should put in 4. Lila, walk me through putting 4 in here. 4 minus 5 is? Negative 1 squared is 1. So 4 comma 1. You put in 4, you got 1. All right, now can you graph? Over 5 up 0 is right there. 1, 2, 3, 4, 5. That's 5, 0. 6, 1. You go over one more spot, but you go up 1. 6, 1. 7, 4. You go over one more spot. So this would be where 7 is. 7 comma 4 is like up there. 4, 1. Over 4 up 1. That's right there. And can you see what's growing here is a little baby parabola? Yes. Don't we need a negative? Oh, yes, okay. So if we do put in a negative, the bad part about that rule is that sometimes you end up off the graph. So, but you'll see that at least. Negative 1 goes in. Negative 1 minus 5 is negative 6. Negative 6 squared is 36. Do you get how that goes way off the graph? And let me show you why. If I put in negative 1, I got to go way up there to see where my dot would be, you know, because it's negative 1 comma 36. So that would be off the screen. If you extended it out, it would eventually get over there. You know what I mean? It would just take forever. Okay. All right. Domain, range. Domain's how far to the left this thing goes. But there's an arrow tip. That should tell you something. What's way to the left? Way to the left. Say it if you know it. Negative infinity is correct. And what's way to the right? Infinity. The range of this thing, well, how low does it go? The lowest, there's the bottom. The lowest it goes is 0, and it touches there. To how high does it go? Infinity. I hope that those are getting easier for you. But you don't have to have domain and range mastered until next week. But if you're shaky on it, make sure you ask me for help. All right. So I said there was 2 things you had to do today. 1, you have to be able to make points like this. You stick in any number you want into the equation. That was on week 1. You had to learn to stick numbers in equations. Then you got to be able to graph those points, which we just did. And we got these dots right here. And then you have to do domain and range from last time, like that was before the weekend. Domain is left to right, range is low to high. What's the last melon? Here's the last melon. Everybody, write this down and take really good notes on it because I'm about to tell you like 10 things that are all on your next test. Copy this, please. You have to know all of these things. You have to know that that 5 there is going left comma right goes on the inside. That's kind of like domain. Left and right are on the inside. You have to know that on the outside is up and down. And it could be down comma up, doesn't matter. So the inside is horizontal on the inside, and it's vertical on the outside. What are you talking about? Left and right is a horizontal thing. Do you get a horizontal line? Is a line that goes like the horizon. And so the stuff on the inside here is like the horizon line. And that's horizontal and it's left and right stuff. The stuff on the outside of the function is telling you how far up and down to move your function. And it's vertical on the outside. So I'm going to sneak to the end of this one and say, I can tell you where this parabola, it's like a U shape, has moved. Here's the parent parabola. We always start by, like, there's the baby one. That's the brand new little easy parabola, y equals x squared. But I just did some stuff to it. I made it more grown up. It's now more complicated. It's 5 to the right and up 7. I just moved it 5 to the right and up 7. Do you get my U shape? Just moved. It isn't at 0, 0 anymore. It's just been moved to the right and up. Here's the notes you got to take. You got to know what high vo means. Horizontal, inside. Vertical, outside. You got to know that the inside is left and right, which kind of goes with horizontal. And the outside's up and down. The next thing you have to know is that you can trust. No, wait. Trust is on the outside. You can trust the outside number to be like what you would expect. You can trust it. Like if this is up or down, would you agree plus 7 seems like it's up 7? Yeah, and it is up 7. And you can trust the stuff on the outside. But you can't trust the stuff on the inside. Don't trust. Are you taking notes? Take notes. I'm telling you, this is so important that if you don't understand the stuff I just wrote there, you won't pass your next test. You have to know which one's left, right, and which one's up, down. You have to know which one is horizontal and which one's vertical. I just wrote H for horizontal. I hope you're okay with that, and V for vertical. And you got to know which ones you can trust and not trust. Plus 7 seems like it's on the outside, and I said to trust it, so that means up 7. This one should seem like it's left 5 because, let me show you where minus 5 is on a graph. Minus 5's, 0 is where you always start, right? Didn't I just go to the left? So it should seem like it's left 5. It's actually right 5. And this is actually up 7 because we trust it. Did you take all those notes yet? Write these down. This is huge. That's like 1, 2, 3, 4, 5, 6, 7, 8 things you have to know for your next test. They're all on the test too, every one of them. Yes?
Is it only left 5, or is it only right 5 because it has the exponent?
Okay, the question was, is it only left 5 or right 5, which in this case it's right 5. Is it doing, I think what you're trying to say is it doing the opposite of what you would think because of the exponent? And yes. But it's even more, not just because of the exponent, it's because of the function itself. So this one's a quadratic function. If it was an absolute value, the absolute value is what makes it do the opposite of what you would think, because if you put in a -5 on an absolute value, it actually turns into a +5. Okay, so it's the function more than just that it's squared. All right, so I think this is one of these where you're gonna, the first example seems really complicated, but after we do like 2 or 3 of them, you'll be like, oh, this isn't that bad. Okay, so watch. Y equals absolute value x minus 3 plus 4. There's an inside and there's an outside. The stuff on the inside, horizontal inside, high, low. That if I wanted to just have you memorize one little trick, high, low helps a lot. Horizontal inside, vertical outside. So that is a horizontal move of 3. And then I have to remember, do I trust it or not? -3 seems like it's to the left. That's where -3 is. It's over here. But it's not going to move to the left. This one's going to go right 3. Don't trust the inside. And this is seeming like it's up 4, and it is up 4. You can just trust those. I've got a good story about not trusting the inside. And it's, first of all, one of my friends went to jail for about 8 years. I know, it's kind of crazy. I didn't think that would ever happen to me, but it did. One day, he's just like, you know, around and hanging out with everybody, and then all of a sudden he gets arrested, and I'm not telling you what he did, but he pled guilty to it, and he ended up going to jail for 8 years. So he said that the jail is called the inside. Like when you're somebody who's been to prison, you talk about your time on the inside. All right, so that kind of made me think of these functions. Like, I can actually use this. So then I'll just say that you generally can't trust the people that are on the inside. Like the cellmates that you have, you can't always trust them. Sometimes they beat the crap out of you. Sometimes they, you know, they do mean things to you. So people that are on the inside in prison with you, you probably don't want to trust them. You could probably trust the people on the outside, like your family, who still loves you, and his wife waited around for him. You can trust the people on the outside. Can't trust the people on the inside. I have a long story, but it's too long for today. So about the inside and how this one person, he almost died in prison because he couldn't trust that person. But just trust me. Don't want to be on the inside. And you can't trust all the people that are on the inside. All right, so there's my inside brief version of the story. Don't trust that stuff. If that should seem like it's left 3 and it's actually right 3. This you can trust. The function all moves up 4. So let me show you what it looks like. It's a V shape. That's what they start it as because that's what absolute values look like. Absolute value of x looks like that. It's a V shape. Really handy if you memorize that. So many little things to memorize. Then it moves right 3 and up 4. That means the little v is now up here somewhere. Do you get I moved it to the right and up? Yes?
If it's +3, then it would be to the left.
Then it would go to the left. You are correct. If this had been a plus, it would change which direction it moved. And if this had been a minus, and then it wouldn't have moved up 4, it would have moved down 4. All right, here's another one. The square root function is the weirdest looking one. We already did this. That's the parabola. This one's the absolute value. The weirdest one is this one. It starts at 0, 0, and then it kind of slowly rises, and it's like a ramp. That is the square root function. Let me show you why. XY chart. I put in any numbers I want. Square root of 0, 0. Square root of 1, 1. Square root of 4. Do you remember how to do square roots? What's the square root of 4? 2. There's a button on the calculator to do square roots for if you want. But look, I got 3 points. 0, 0. Doing 1, 1. Doing 4, 2. Doing, see how that square root graph is going? That green one is the square root graph. So if I take a square root and I say, I don't want it to be in the normal spot, I want to go plus 5 to it. I just moved it somewhere. Where would it go? And is this the kind of number you could trust or not? Neverman, do you feel like we can trust that 5 or not?
Yeah.
Yeah, because it's on the outside. And horizontal's on the inside, so that's a vertical thing on the outside. So it's a vertical, I can trust it. That's up 5. Raise your hand if you knew I was going to say up 5. All right. Okay, cool. Then this whole green graph would move up 5, and it would look like that instead. Everything just moved up 5. All right. Now, if you understood every single thing I said today, then you'd be ready for the test now. I'm serious. This is like the whole test. And we have a week and a couple days to practice it and get good at it. But today was really intense, I know. But it's going to be, you know, there's a lot of little things to remember there. Like, where's the horizontal? It's on the inside. Where's the vertical? It's on the outside. Can I trust? Which one do I trust? Remember, the inside is like prison. Don't trust people in prison. The outside you trust. All right? And then left, right is on the inside. Up, down is on the outside. So many little rules. If I just give you this graph, you're supposed to know that's the square root graph, Mr. Server. And you might not know them yet. But by next Wednesday, hopefully you'll know that. And then if I go, I want to move it up 3, then you're going to say, well, then you should go plus 3 on the outside because that moves it up 3. Yes?
On the absolute value question,
Absolute values are a V shape. And keep going.
you said that if it was a positive inside, the absolute value would be on the left. But
Wait. Okay, so let's talk about that. First, let me graph the regular absolute value. So do you get that that's a V shape and it looks kind of like that? Are you with me so far? Okay, now if I do something on the inside, if I put a negative 3 in the absolute values, do you get that would change it to positive 3?
yeah.
Okay, but if I put x minus 3 in here, the key distinction is this. Do you get that this should seem like minus 3 is like over here? Doesn't that seem like I'm dragging it to the left? But I'm actually going to go to the right. And this would move right 3. So there is a positive angle to the minus 3, but that's if you put in a number and then you absolute value it, then it'll change.
But you said if it's a positive, then it goes to the left.
So let's go like this. Do you get if I change this to a plus? Now it's going to go to the left. It's always confusing on the inside. Even in my honors classes, people get confused by these. Now, you might be thinking, like, I thought that I had this down. Think to yourself, if I'm picking between left and right and I'm on a graph, where is 3? Where is positive 3? It's over there, which is to the right. So it actually goes left. Okay, I know, it's confusing. And if you were like, Mr. Server, I think you're wrong, and that's okay, I know you're not really saying that, but if you really were thinking, I think he's got it wrong, use Desmos, graph it, and it takes like 5 seconds, and then you'll see where is this thing actually. And I promise you, that one is a V shape, that is left 3. Feels like it's to the right, it's not, it's to the left. Okay, you've made it. This is the part where it's just a worksheet from here. So clear off your desks, accept something to write with, and then I'm going to give you this worksheet. And we'll do some together. Looks like this for those at home. Find that worksheet. Okay, so first off, this looks super intimidating because there's so many questions, but it was meant to be like one where you could cut down the middle of the page. So cross off all of those. They're the repeats of the ones on the top. So cross off the bottom half of the front page. Okay, next, let's go in and do, how do we graph the absolute value of x? Well, option A, you've got a good short-term memory, and you know it looks like a V shape. I'm done. It goes exactly at the points, I'll be more specific here. It goes exactly like this, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and it also goes up this way. So, I'm fine with you just drawing a V. We'll keep life simple on that one. Because you might be able to remember that on the test. Okay, how about this square root? Now, that's going to be harder. So, I want you to practice this anyway. Make an XY chart off to the side. You can put in any numbers you want, but some work nice and some don't. Lila, tell me a number you think would work nice to put in for this X right here.
4.
4 works nice, I agree. Do you guys have 4 memorized? Square root of 4 is? 2, good. Then, here's an example of one that doesn't work nice. I could put a 3 in, but who knows the square root of 3? Anybody got it memorized? Then you probably don't want to do 3. Just erase it. Don't do 3. What's another one that works nice? 0. And 9 work nice. Square root of 0, if you didn't know this, 0 times 0 is 0. So the square root of 0 is 0. And we're making points here. 4 comma 2, that's a point. You go over 4, you go up 2, you put a dot. 0, 0, put a dot. Now I'm going to put in 9. Anybody have that memorized? Square root of 9? 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's okay to do this, but it wouldn't have been required on the test. I went off the graph, and that's where 9, 3 would have been. How about one more point? What's another thing you can square root nicely? 1. A lot of people don't think of 1, but 1 works. Because, think about it, you're trying to find something times something that'll make 1. And what's the answer? 1. So 1, 1 is a point on this graph. And then if you connect the dots, you see you've got the square root graph. I told you that's what it looked like, and now we got it by making points. Do you see that you don't really have to memorize what it looks like? Because you could make points, but it's a lot faster to know that that's what it looks like. I have that memorized. All right. X squared, I kind of got it memorized. I know it looks kind of like that, but you would definitely get it marked wrong if you put that, because that's way not exact. So make an XY chart. Pick a number like 2. And then you go, okay, if I put in 2, 2 squared is 4. 2 comma 4 is one of your points. And I did say you're supposed to put in a negative, so let's put in -1 right now before I forget. What's -1 squared? If you're bad at this, you'd grab a calculator and you go -1 times -1, and what do you think the answer would be? 1. Good. Okay, so these are just graphing. That's going to be pretty easy. This is domain and range. Let me help you, because it's a little weird. Domain, range. Have you memorized yet that domain is left to right? You either knew that or you didn't. I'm going to write it. If you do, it'll increase the chance you remember it. Domain goes from left to right. Does this go forever to the left? Be careful. Those are not arrow tips. Arrow tips mean infinity. There's no arrow tips. There's no infinity here. So does it go forever to the left? No. How far to the left does it go? -20 is correct. Now this is getting really picky, but that's what math does. Does it touch -20? No, it does not. How do I know that? Because it's an empty circle. That's our sign for it doesn't touch that. Gets really close to it, doesn't touch it. And now we're going domain, and then we go from left to right, and then what's the other side of it? 10, very good. You guys try to figure out the range, and I have a visitor. I'm going to pause for a second. And then when you're done with these two domain questions, flip it to the back side, and there's more joy and goodness waiting for you there. So, just wrapping up the video here. On these problems, you want to make an XY chart. Pick some numbers. I suggested these would be good ones. You graph it, and you get your domain and range done. And that's how the back side of the worksheet looks. That's all I got for you for the video for today.